Okay, this is question 9 on the 2018 WJC additional maths paper. Let's see what we got. The diagram shows a rectangular base pyramid. So if it's a rectangular base pyramid, I know that these corners, even though they don't look it, particularly not with that angle, they are right angles. Okay, another one in there and another one in there. I'm just going to stick with those, just so we know that they're right angles. And that then makes this triangle a right angle triangle. Okay, it doesn't look it, but if you looked at it from up above, because it's a rectangular base pyramid, that would be a right angle triangle. So the length of the rectangular base is 4, the width of the base is 3, and each slant is 6. And we want to calculate the perpendicular height. So this is what we're trying to work out. So that's what we're looking at. We just got to figure out how to get there. Now, if each of these slants are 6 centimetres, that means that that point there must be directly above the middle of this line. Okay, what that means then is that if that's the middle of the line, if we worked out the length of this line, then we can work out the length of halfway. Okay, we can work out the length of half of it. And by doing that, then that's what we end up looking for in order to try and find this height. Because this is essentially a Pythagoras question. So if I look at the base, what we end up with here is we end up with a very well-known right angle triangle, the one that hopefully you'll be familiar with. That if this is a 3 centimetres and this is a 4 centimetres, you should know that this is 5. Okay, it's a 3, 4, 5 triangle. If you wanted to use Pythagoras to do it, then that's absolutely fine. So we know that that whole length is 5 centimetres. So that implies that this length here, I'll call it AB. So that implies that AB is going to be half of 5, so 2.5. Okay, now I've got that, I can use this vertical triangle with the AB in it and the 6 to work out the perpendicular height. Let's call the top of it C, so the perpendicular height is AC. Okay, so let's go with this triangle. Oops. So A, B, C. I know that BC is 6 centimetres. I know that AB is 2.5 centimetres. And I'm looking for AC. So if I use Pythagoras, Pythagoras says that A squared plus B squared equals the hypotenuse squared. So for me, the hypotenuse is 6. So I'm looking at one of the other two sides. So I'll call this one 2.5. I'll call that the B. And on this side AC that I'm looking for, that's going to be this value here, A squared. So I end up with AC, which is that length I'm looking for, squared, plus 2.5 squared equals 6 squared. So if I want AC on its own, I can get AC squared on its own first by taking off 2.5 squared from both sides. So if I do 6 squared minus 2.5 squared, that gives me 119 over 4. So then my AC is going to be the square root of that. So the square root of 119 over 4 which means that AC, this perpendicular height, is 5.45 centimetres to 2 decimal places.